All right, on 45 here, we only have to do 45 part A. A fairly straightforward problem. We have a car. It's accelerating uniformly from rest to 10 meters per second in a time of 3 seconds. Okay, so anytime something's speeding up, you should recognize that the energy is changing. What kind of energy is changing? Kinetic. Anytime that there's a change in speed, we know that we have a change in kinetic energy. Anytime that there's a change in height, we have a change in potential energy. And we should also know that from the work energy theorem, that work is equal to the change in energy, right? In this case, we would say the change in kinetic energy. Now, the other class was kind of having an issue with this and just saying that I was like, oh, you're just pulling equations out of nowhere. I'm pulling equations out of nowhere. We know the equation for kinetic energy. And when I say change in kinetic energy, that's not a crazy idea to say, well, we know that change in is always the final value minus the initial value. So in other words, all we want to know is work. So we can just solve for W here, and that W is going to equal KE final minus KE initial. Now, which one of these cancels out? Which one of these two terms here cancel out? KE initial, because it says starting from rest. So we know that we have initial speed of 0, which makes the initial kinetic energy 0. So the equation becomes simplified to work is just equal to 1/2 mv final squared. We have m, we have v final, that's this guy. So 1/2 times the mass of the car, which is 1,000. That's not the mass of the car.
The only thing I didn't get about this one is when you incorporated time.
When I incorporated time.
There's time.
Well, there are other parts of this that I didn't assign yet, so that's where that comes into play. So yeah, for part A, you didn't even need to use the time. So 1/2 times 15,000 times 10 squared, and that comes out to what? 75. Wait, no, not 75. It's not 7,500. It'd be 75,000. Is that right?
Yeah,
750,000 joules, or 7.5 times 10 to the 5th. Pretty cool with that one.